Hello there again! This video is a continuation of our topic on minerals and rocks. For today, we will talk about mineral groups. Let's start! The most stable and least ambiguous basis for classification of minerals is based on their chemical composition. There are 7 mineral groups. We will talk about them one by one. First, let's talk about native elements. Native elements are minerals that form as individual elements. They are categorized into 3. First, into metals. These are minerals with high thermal and electrical conductivity, typically with metallic luster and with low hardness such as gold, lead, and copper. Semi-metals also are minerals that are more fragile than metals and have lower conductivity such as arsenic and bismuth. Non-metals are non-conductive like sulfur and diamond. Let's talk on the second mineral groups, which is the silicate. These are minerals containing the 2 most abundant elements on Earth's crust, namely silicon and oxygen. Some examples of this are quartz, olivine, and talc. The third group of minerals are under oxides. These are minerals composed of oxygen and iron combined with one or more metal ions such as magnetite, hematite, and chromite. Sulfates also are minerals containing sulfur and oxygen in the form of sulfate anion such as gypsum, barite, and anhydrite. The next group are under sulfides. These are minerals containing sulfur and a metal. Most sulfides are sources of economically important metals such as copper, lead, and zinc. Other examples also are pyrite, galena, and bornite. Carbonates also are minerals containing the carbonate anion combined with other elements such as calcite, dolomite, and malachite. Lastly, we also have halides or the halogens. These are minerals containing halogen elements combined with one or more metals such as chlorine, fluorine, and halite. The previous slides we had talked about the group of minerals. Now let's move on to rock classification. Why do we need study rocks? Well, rocks are natural substances consisting of aggregate minerals clumped together with other minerals through natural processes. They are like other minerals that are product of natural cyclic processes. Therefore, rocks contain minerals. Rocks are classified into 3: igneous rocks, sedimentary rocks, and the third one, metamorphic rocks. Let's talk about them one by one. Let's talk about igneous rocks. These are rocks formed from the solidification of molten rock material such as magma or lava. Don't be confused on the difference of magma and lava. Magma is a molten rock material beneath the surface of the earth, while lava is a molten rock material extruded to the surface of the earth through volcanic or fissure eruptions. With this, molten rock materials can solidify on, first, either below the surface of the earth, and that is why they are called as the plutonic igneous rocks or the intrusive igneous rocks. Or they can also solidify at the surface of the earth. That's why they are called as the volcanic igneous rocks or also called as the extrusive igneous rocks. As the magma crystallizes, minerals are also formed. The second type of rocks are classified under sedimentary rocks. They are rocks that are formed through the accumulation, compaction, and cementation of sediments. They generally form at surface or near surface conditions. Sedimentary processes at or near the surface of the earth includes weathering of rocks, sediment transport and deposition, compaction, and cementation. Sedimentary rocks are classified into two. First, let's talk about non-clastic, chemical or biochemical sedimentary rocks. They are formed through evaporation and precipitation from solution or lithification of organic matter. They are also classified as evaporites, precipitates, and bioclastics. For examples, you can refer to the module provided for you. On the other hand, clastic or terregenous sedimentary rocks are formed from grains, matrix, and cement of clastic rocks. Clastic rocks are commonly classified based on particle size. Some examples are sandstone and shale. For more examples, please refer to the module provided. Finally, let's talk about metamorphic rocks. These are rocks that are formed from the transformation of pre-existing rocks such as igneous, sedimentary, or metamorphic rocks through the process of metamorphism. The question is, what is metamorphism? These involve changes in the physical and chemical properties of rocks in response to heat, pressure, and chemically active fluids. There are two types of metamorphism. First is the contact metamorphism. In here, heat is the main factor. This occurs when a pre-existing rock gets in contact with a heat source such as magma. This process also creates non-foliated metamorphic rocks. Non-foliated in a sense that crystals are arranged in random manner, just like hornfels. On the other hand, regional metamorphism also is the second type. Pressure is the main factor in this process. It occurs in areas that have undergone deformation during orogenic event resulting in mountain belts. This process creates foliated metamorphic rocks. Foliated is because crystals are aligned in layers, such as schist and gneiss. This table here shows the different common metamorphic rocks, just like slate, phyllite, schist, gneiss, anthracite, hornfels, quartzite, marble, and metaconglomerate. These are some examples of metamorphic rocks. I know some of you are wondering what will happen to the three types of rocks as time goes by. Well, rock cycle can explain us the process. This model can describe all the processes by which rocks are formed, modified, transported, decomposed, melted, and reformed. It can also tell us the constant recycling of minerals, and it can illustrate how geologic processes is occurring both underneath and on the Earth's surface that changes a rock from one type to another. So it's possible that from an igneous rock, it can turn into metamorphic, from sedimentary to metamorphic, and so on and so forth. Let us examine the rock cycle below. This illustration explains how one type of rock transforms into another type of rock. Let's begin with the process of weathering and erosion. Through the agents of erosion, all the sediments will be deposited in the places with lower elevation. Years goes by and it will be formed into layers. Compaction and cementation follows, forming now sedimentary rocks. Due to heat and pressure, the sedimentary rocks can turn into metamorphic rocks due to metamorphism processes. As years pass by, metamorphic rocks can undergo cooling and it can be solidified below the surface of the earth, forming the plutonic igneous rocks, or when eruption takes place, they can be deposited in the surface of the earth, called as the volcanic or extrusive igneous rocks. After this, it will repeat the process. It is also possible that from an igneous rock, it will be converted into sedimentary rocks, into metamorphic rocks, and turning back as sedimentary rocks again. A rock cycle is one of the non-stop processes that occurs beneath and on the surface of the earth. This will be the end of our discussion on rocks and minerals. Now, you are ready to do your assessment number 2 and performance task number 1. Thank you so much for listening and enjoy doing your activities. Have a great day!